Welcome to Smart City Viewpoints at ARC Advisory Group. I'm Jim Frazer, Vice President of Smart City Research here at ARC. Our guest on today's episode is my colleague, Eduard Fidler, ARC's Transportation Analyst. Eddie, thank you for joining us today.
Thanks so much, Jim. It's my pleasure.
Hey, that's great. Our topic today is electric vehicles, and in particular, their impact on fleet operations. So let's jump into the discussion with Eduard. Eddie, can you just comment on, what are electric vehicles for those of us who might not be involved in the industry?
Sure. That's as good a place to start as any, I think. So an electric vehicle is a vehicle that uses an electric drivetrain. So the architecture, just from a high level, is you have a lithium-ion battery on board, and then you have electric motors that produce your propulsion, and they're a lot simpler compared to their competitors, the internal combustion engine, which, of course, as we know, has a liquid fuel tank, a controlled combustion reaction, transmission, fluids, and gunk, and all these moving parts. But within electric vehicles, you have two main families. You have the plug-in hybrid electric vehicle and the battery electric vehicle. So the plug-in hybrid, it houses both an internal combustion engine as well as a relatively small lithium-ion battery with an electric drivetrain. So the thinking there is, if you have a commute of maybe 10 miles and you do some errands every day with your vehicle, you might not need a giant 200-300 mile range lithium-ion battery. Maybe you could just use a small one that has maybe 30-40 miles of electric range. So that's maybe what you can use 90% of the time. And then on the occasion that you need to take a long highway trip, you can treat it as a standard, just internal combustion vehicle that you can just gas it up. So it makes a pretty big impact in terms of emissions and all that, but it's a hybrid, it's both.
Okay.
And then in comparison to that, you have a full battery electric vehicle where it has no fossil fuel powertrain, just a battery. So you live and die by that battery.
Great. So I understand that there's two varieties of electric vehicles. Can you comment on, what really are the strengths of electric vehicles against internal combustion engine vehicles, and perhaps even in maybe you can comment on a variety of different markets, from construction vehicles to other markets you might be studying?
Yeah, for sure. So this is where things get interesting in terms of making purchasing decisions and all that. So an electric vehicle is, again, it's powered by a lithium-ion battery. So it's basically silent. It provides instant torque. And so electric vehicles convert energy to propulsion a lot more efficiently than internal combustion engines do. So in a lot of cases, you're seeing an MPG equivalent of about 3x that of a fossil car. So that's a big deal. They generally enjoy per mile energy costs that are about half or less than half of an internal combustion vehicle. Of course, that varies by local fuel prices, fuel tax, and electricity prices. But overall, it's less than half the cost per mile, which is a big deal. Another piece is that EVs enjoy zero tailpipe emissions. They actually don't have a tailpipe. And of course, as we know, air pollution kills tens of thousands of people just in the U.S. every year. And that's air pollution just from the transport sector, not from power plants. So it's a big deal. Now, of course, upstream, right, where the actual power is being generated, the emissions still count. But as we know, a lot of areas in the U.S. are actually cleaning up their grids very quickly. So, for example, in the Northeast where we are, and in California, the grids are so clean that makes a big impact for the EVs. And they're getting cleaner every year, of course. Another piece here is that EVs have far fewer moving parts than fossil cars, owing to their simpler drivetrains. So what that means for an operator or any kind of an owner is you need far less maintenance. So we're talking about no oil changes, no oil filters, your spark plugs won't go, the wiring there, the ignition coil, catalytic converter, the timing belt, there's no engine sludge, emissions checks, and I can just go on and on. So that's a big deal, especially when you're an operator.
That's interesting, Eddie. Earlier in my career, I worked quite a bit with the electric motor industry, and I often wondered why electric motors were not used to power vehicles, in particular because the torque curve of an electric motor seems to be much better suited to transportation, meaning there's maximum torque at 0 RPM, and it reduces as the RPM increases, whereas internal combustion engines have 0 torque at 0 RPM and really only achieve maximum torque, up at the 2, 3, 4, 5,000 RPM, which has required, the development of very sophisticated transmissions so that your vehicle works in that sweet spot of high torque.
Mm-hmm.
So over time, it's great to see that this industry is happening.
Absolutely, and I think an average driver doesn't really think about their torque too often, but when it comes to more performance vehicles, off-highway applications, workhorse vehicles and fleets, they care. I mean, if you're a municipal worker, using in waste management, you want your truck to pull out and you're not going to go too quickly down a city street, and it's silent to boot, so you can make your route at 6 in the morning and no one complains.
No, exactly. But that torque curve, if you are a municipal work truck, is very good if you're pulling a trailer or something else. Let's move on. So, exactly how does charging work? What are charging platforms? Do I need to be plugged in? Are there, let's cover the gamut of how I charge a vehicle and how does that work?
Sure. And I think this is one of the most important aspects when you talk about EVs and especially the switch to EVs, because we all grew up with fossil cars. We understand how gas stations work, right? So with an EV, things are very different, but a lot of people find it's far superior. So just to start with, I know that the conversation usually revolves around the network of fast chargers, such as on the highway, much akin to a gas station. But I think it's more useful to start the conversation from how do people who own EVs today actually use them and charge them. And the research shows, the data show that the vast majority of charging happens at home at very low power levels. So in the charging world, you have level 1, level 2, and DC fast charging units. So a level 1 unit, it uses 110 volt. You can literally plug it into your outlet at home, and it charges your vehicle at just a few kilowatt. And for reference, a standard Tesla Model 3 battery with full range, 60, 70, 80 kilowatt hours, just for reference. So that's slow. But the fact is, if for the most part you've only driven 20 miles, 25 miles that day, and you come in at 6, 7 o'clock to your home and you plug in overnight, even that slowest of the slowest charger tops off your tank or your battery. That's it. The next level up is a level 2. So to install a level 2 system, you need to work with 220 volt. So if you're at home, you do need an electrician to come and make an upgrade, but it's not a severe upgrade at all. And those charge at about 5, 6, 7 kilowatt. And that's what most private EV owners use. And then if you're away, if you're on a trip on the highway, you might go to a DC fast charger. So these can, at the low end be 25 kilowatt. They're usually 50 to 100, 120. And a lot of systems are upgrading now to 150, 250, 350 plus in the future. So those are the 3 classes of charger, but most people really use the level 1 and 2. So the conversation around, how extensive a network of DC fast chargers do we have or do not have, that's actually a secondary conversation, surprisingly enough.
So, Edward, you've described the 3 types of chargers: level 1, level 2, and DC fast charging. How do they impact that? What's perceived as a major obstacle is charge time. How do they impact the charge time for each vehicle?
Sure. I think that's a great question. That kind of helps put it into layman's terms, so to speak. Okay, so if a standard full range battery today is 60 kilowatt hours, what that means is if you're charging with a level 1 unit, again, just plugged into your wall, and maybe that's 3 kilowatts. Obviously, that's going to take 20 hours to reach 60 kilowatt hours. That's not something you would do. But so that's more suitable if you've only depleted by, say, 10% or 20% from an average day commute and errands and all that. So in that case, if say you need to replenish 6 kilowatt hours at 2 kilowatts, that's 3 hours. Easy. When you upgrade to a level 2, maybe you're working at 6 kilowatts. Of course, your full battery at that point is 10 hours. But again, if it's just a quick touch-up, it's literally an hour in your garage or your driveway. So again, those 2 are more suitable for either if you're parking basically overnight or if you only need a top-up. If you've depleted your battery, say you're on a highway trip and you're relying on DC fast charging, well, then look, a 50 kilowatt fast charger, a standard, fills you up in just about an hour. A 120 does the same in about half an hour. And then the real fast chargers, the 150, 250, 350, it's a matter of minutes. And that's going to be comparable to just using a gas station.
Wow, that's great. Thanks for that insight. Now that we've reviewed the variety of chargers, how charging works, and the variety of EV technologies that are out there, what markets is this impacting first and most dramatically? And I have a feeling it probably is fleet operations. So can you talk a little bit about that?
Yes, for sure. So I guess the right way to go about this is just to circle back to some of the advantages of electric vehicles, right? They're much simpler to operate. They usually enjoy far lower per mile energy costs, and they really help in terms of air pollution. So let's just think about it. If I am a normal citizen and I'm making a vehicle purchase decision, I might see, well, hey, a full EV is still quite a bit more expensive usually than a fossil car. And yes, I'll benefit on operating costs, but the fact is I drive a couple dozen miles a day. I'm not really being penalized for pollution. I don't really have a public image as far as being a clean, citizen or one who's polluting or anything like that. So I might buy one, I might not, right? It might make sense for me, it might not. But if you're a fleet owner, say it's for last mile urban delivery or for ride hailing or a taxi company, the crux of this is that you have a far higher vehicle utilization rate than a regular citizen. So a New York City taxi cab is estimated to drive about 70,000 miles per year, compared to an average citizen of maybe 12,000. So if you think in terms of total cost of ownership, you have a higher upfront cost. And then if you're a taxi cab, you are squeezing out those operating benefits very quickly. You might even go through the full useful life of the vehicle in 3-4 years. And so the economics simply are a lot more favorable, because when you consider the time value of money, if you have a much higher upfront expenditure, that sort of blows up over 10 years. When you consider your hurdle rate, your internal rate of return. So the economics are totally different. And on top of that, if you're a fleet, say you're UPS or a taxi company, you do care about your public image. You do care about public relations. And so if you can say, hey, we have a fully green fleet, no air pollution, silent, no noise pollution, it's a huge benefit for you. So that's why we here at ARC are predicting that fleets are definitely going to be at the forefront of electrification. And we are seeing essentially the crest of that wave. We're seeing the beginning of it. So a lot of municipal buses are toying with electrification. And they're toying in the West, but in China, for example, there are tens of thousands, if not a few 100,000 electric buses already. On top of that, you have delivery. So UPS, DHL in the West is already experimenting with EVs. Of course, we have Waymo from Google. They've ordered a few tens of thousands of EVs. And probably the biggest piece here, and this was very recent, this was last week or 2 weeks ago, Amazon has ordered, was it 80,000 or 100,000 electric delivery vans from Rivian.
Yep.
So this is a big deal. This is a really big deal.
That's fascinating. So you actually answered my next question, which is, what are we seeing now? That's fascinating. Can you look forward in time about what do you expect for the EV industry in the future? In particular, not only vehicle technologies themselves and evolution of batteries, but how about the charging platforms and management of all of that? How would you expect that industry to evolve?
Yes, so this is where the conversation can go in a lot of ways. And being a transport nerd and an EV nerd, this is where I'm going to geek out. So to start with the charging platforms, I think you need to think about just the sheer amount of power that EVs are going to take if our predictions are correct, that a lot of fleets are electrifying. And you couple that new large load on the grid with the prevalence of renewables, which are intermittent, right? So now you have this balancing act that the grid has always had to manage, but now there are even more variables. So one hurdle for an e-fleet is when you interact with your local grid, you have to deal with very onerous demand charges. So if you hit a high peak demand, they're going to charge you maybe 4x, 10x, really exorbitant prices for your energy. So there's a ton of value here to be derived from utilizing a charging management platform that can optimize your charging in terms of your sheer energy usage among the vehicles that you have in your fleet. So the charging side is really important. And over there you have some vendors that are just providing these software suites to operators, but you're also seeing a new model emerge, or there's a company called AmpliPower. So they're providing charging as a service. So if I'm a local taxi fleet, The way that you operate when you're a fossil taxi fleet using fossil fuels, you pay a vendor to come in to your depot and they fuel up your vehicles every night. You pay by the gallon of fuel. Now, imagine if that taxi fleet had to figure out their own network of gas stations and that whole infrastructure. It would be crazy. But that is what you need to do if you're electrifying. You set up your charging stations and software, and you interact with your grid for grid service upgrades and whatever else has to be done. It's really beyond your purview, and you don't want to have to deal with it. So what Amply does is they take the headache and the risk out of all of that. You pay them for every kilowatt hour, and they take care of the rest. There's also another model. It's even more kind of forward thinking. It's from a company called EIQ, also on the West Coast, and they offer full EV fleet as a service. So that's a whole other beast. So that's the charge management platforms. The other piece is, and this is only just starting, but when you have huge numbers of EVs on the road and on depots, the grid could actually utilize all of that energy storage that they have on board to create what's called the virtual power plant. So there's a concept of vehicle to grid, and there's a lot of value to be derived there for the entire grid system and for the EV owners, though at the cost of increased battery cycling for the vehicle's battery. So
that's interesting.
There's a lot, yeah. There's a lot there.
That's very interesting, Edward. In particular, I'm looking forward. I know that you're doing some research in the next few months, and we'll be preparing some studies on electric vehicle charging networks. And in particular, I'm looking forward to the breadth of different approaches to that market, because a residential EV charger platform might look quite a bit different than what a taxi cab company or a last mile food delivery service might have, because managing those demands are a little bit different. In the residential domain, well, it may come down to managing me and my 3 or 4 neighbors who are on the same transformer. We all can't plug in and charge at a maximum rate at the same time. So how does that bartering for that maximum demand on that one transformer work? Mm-hmm. The business case, around that platform at the taxi cab depot is quite a bit different. There's going to be a tremendous number of fascinating developments here. We haven't talked about capacitive charging, meaning non-coupled charging, where you might be able to just drive your car over a platform and have it charge, fully charge. There's been some research and work out there looking at installing those capacitive chargers at stop signs, so that you wouldn't get a huge charge, but you would get something. And if it was a lot of stop and go traffic with all the stop sign intersections enabled, you might be able to fill up, top off your battery. Your comments on the virtual power plant, it's electric vehicles out there on the grid are really distributed energy supplies, and very often typically at the 2-3 p.m. peak, where energy is often the most expensive, those vehicles are not in use. If they're private commuter vehicles to work. So that's a really nice match. But you are correct. Some of the battery life cycle discharge warranties need to be addressed a little bit before we move into that future.
They do, yeah. And I think one more point I want to throw out there, as far as where things are going, is around that battery, and more importantly, what you do with it when it eventually is depleted. So say after 10 years, you have your Tesla, you have your Bolt or what have you, and your capacity is down by 50%. So it's time to get that battery replaced. So a lot of EV detractors will say, well, hey, now that thing has to be wasted, and it was a lot of money to replace. But what we're seeing, the direction that we're at least hoping for, and that some players are starting to work towards, is a full secondary market for EV lithium-ion batteries. So that means you go to replace your depleted battery, but then you are able to sell it for maybe $7,000, and that now 30 kilowatt hour battery, which was originally 60, is integrated into maybe home energy storage or into the grid itself. So that's going to be a whole secondary market, and that takes care of a lot of the issues with disposing of lithium and the other metals there. And then if we want to go in the other direction to upstream, there's a lot of rightful concern over mining the metals that go into these batteries. So lithium's a small part of it. Of course, you have nickel, but cobalt is one of the perpetrators here. There's a lot of sort of human rights questions around mining cobalt in Congo, for example. So that's why these battery manufacturers are racing to not only improve performance and capacity, but actually reduce the requirements of cobalt in their systems as well. So we're going to see a lot in the battery ecosystem, a lot of developments.
That's interesting because thoughtful and developers of technology are really embracing the entire life cycle cost,
yes,
which is not only the mining of the materials but also disposal. It's not just your battery in your car in your driveway.
Yeah. Let me just add, if I may, Renault, the European car maker, with their EVs, they don't even. So from the beginning, when you purchase an EV from Renault, you don't own the battery. They're actually leasing the battery to you, and when it comes time to replace it, they take care of the entire life cycle in house. So they're starting the process from the day you buy the car. So I think that's at least an interesting model that might, yeah.
Well, that brings up the question. I know that in the past there's been some discussion about swappable batteries, where instead of charging, you would drive into a gas station and swap out your battery. What's the status of that approach to the market?
Mm-hmm. Yep. So we were originally seeing that a lot for 2 and 3 wheelers. So when we talk about EVs, we talk about usually Teslas and Chevys and all that, but there's actually more electric 2 and 3 wheelers, especially in Asia, than any other type of EV. And so there are already these stations in Asia where you go in and you swap your battery. So it's an instant charge, so to speak. But there are definitely some issues when it comes to a larger battery, like under a Tesla. There's just the shoe leather costs, so to speak, just the turnover there. But where you are seeing these ideas is in off-highway applications. So think about mining. There are lots of benefits to electric mining vehicles for fully underground operations, right? Because a huge cost for miners is the ventilation systems, these massive shafts and fans they have to run to make the air not quite breathable, but technically safe for their workers, right? Still not great. You have your regular sort of underground particulates, but then you also have all this exhaust from their massive diesel engines. So EVs are a natural fit there for pollution, for noise, for vibration. But the point is, when you're working underground, I mean, every hour is very expensive. So you don't want to charge these massive batteries. So the battery swap idea is coming aboard in mining. So they've invested in very modular battery systems that you can replace quickly. So I think we're going to see more of that where it's economically viable for sure.
Well, we're just about out of time. I do know that it's just a fascinating domain, electric vehicles, with companies like Harley Davidson announced an electric motorcycle. Mercedes-Benz has announced an electric scooter. So that this vehicle electrification is touching and every part of the market, and is really creating new partnerships and new market entrants. Who would have thought that Mercedes-Benz would make an electric scooter, for example? But Eddie, do you have any last thoughts, and then we'll wrap it up?
Yeah, for sure. So I think you're spot on that this area is just dynamic, and it's super important as we're facing ecological challenges, air pollution and climate change and noise pollution and everything else. So I think people are putting their ears to the ground and understanding that they have to get ahead of this. So I'm glad you mentioned Mercedes. They're of course owned by Daimler, right? So if we circle back to the Amazon announcement I mentioned earlier, when Amazon started building out this fleet, they bought 20,000 delivery vans from Mercedes, and they were fossil vehicles, and they caught a lot of flack for that, including from us. But this next announcement was all EV, and none of that business was going to Daimler. So it was somewhat of a message and somewhat of a wake-up call. And so Daimler, for example, is also investing in electric heavy-duty, like long-haul trucks. So the writing's on the wall. And just for closing comments, I think a big part of moving this ecosystem forward is education, because people frankly don't seem to know, their facts aren't up to date on what an EV is. They don't take forever to charge. They don't have a range of just 20 miles. They perform. People love driving their EVs nowadays. And this is going to be a big deal in business, I think, because businesses have a literal incentive to figure out, the real cost and benefits to their purchasing decisions. So that's why we're seeing business take the lead. So it's a thrilling place to be in nowadays.
Well, hey Eddie, it's been great to have you on this podcast on this initial look at electric vehicles. We're expecting to have you back again in the near future.
Great.
To all of those who are listening in, I'd like to invite all of you to join us for future Smart City podcasts. This is a weekly podcast, and don't forget to visit us online at www.arcweb.com. And you can look for the Smart City Viewpoints blog posts there that cover similar topics. You can also follow us at Twitter, at Smart City VWPTS. So thanks again, and we'll see you all next time.
Thank you, Jim. Really enjoyed it.
Thanks, Edward.
Bye-bye.
Thank you.